So, hello everyone. My name is Bartek and I work as a software engineer for a company called SoftwareMill. In my free time, I like to code, what must be very surprising for all of you, enjoy reading books, and from time to time, like read something about mathematics. And it is the reason why we're all here today. I would like to tell you about one of these peculiar mathematical curiosities that can actually impact our life as software engineers. And during this talk, I will try to answer the question, what math is behind allMatch and stream working as it works. But first, let's start with a quick run-through the levels on which math and software intersect with one another. So, first, we have level 0, so binary system, all zeros, ones, and everything related to our software being runnable at all. Then we've got algorithms and data structures, and as you probably know, most of them have some math behind it. Especially if we are in, let's say, the category of graph-based algorithms, which probably originates from mathematics as a science instead of computer science. On the next level, let's say the architectural level, we've got things like CAP theorem, and I know that we can spend here another hour arguing if CAP theorem is okay, that probably in most cases system doesn't behave like it describes it, and it's pretty old. However, it's perfectly suits my case, as it is fully proven mathematical theorem with all the required paperwork around it. And it is less commonly known thing. And as a cherry on top, we've got monads, functors, applicatives, semi-monoids, and other functional category stuff that people try to port into software world. And probably you use some of them in your real life. For example, how many of you are using optionals in your life? Okay, so how many of you knew that optional is a monad? Oh, okay, it's smaller than before, so you just learned something new. Optional is a monad, and you are using monads in your daily life, and you don't even know about it. But let's go back to the base question. Why calling allMatch on empty stream will always return true? I personally always thought that it will return false, because the stream is empty, so there are no elements to perform matching, so automatically it will return false because there is nothing what can match even a condition. However, I learned that I was mistaken. And in fact, it will also return true. So the question around it is, what it have to do with math? It found out that it have quite a lot to do with math, because there is a concept called vacuous truth, which is responsible for all of that happening. And it is a concept from mathematics branch of logic, which describes all the logical statements. I think that you know what are logical statements, at least I hope so. And the statements are evaluated as true because their base condition or antecedent cannot be fulfilled. Or, in more mathematical syntax, assume that we have logical statement S. If P, then Q. Then P is our base condition, and if P is false, S is logically true and is considered vacuous truth. We can also write this law with the help of for all quantificator. This A written upside down, if you didn't hear about it earlier. And we can read it as for all the x's from a set B, if Px, then Qx. And then, if Px is false, for all the x's, our statement is evaluated as logically true and is considered vacuous truth. Okay, now let's try to make it more descriptive with an example, because everybody loves examples. So, assume that if there are any developers in the room next door, then they all work with Haskell. I know it's maybe not the best example, because there will be always some developers in the room next door. We are on the programming conference, and we can safely assume that not all of them works in Haskell, but nevertheless, let's try it and use it as an example. So, here, we have a base condition that is explicitly stated inside our logical statement, and it says that there must be some developers in the room next door. We can also have like implicit base condition that is hidden from us inside the structure of the statement. For example, in statement, all mobile phones in the room next door are turned off. And we have to, let's say, deduce ourselves that the base condition is that there are any mobile phones in the room next door. I know it is not a huge leap of logic, however, we have to make it ourselves. And in both cases, if the room is empty, so there are no mobile phones, there are no developers, or the room is pure vacuum and there are no protons, electrons, neutrons, and whatever particles there, then the statement is evaluated as vacuously true and is considered logically true. So now let's mix a little and mix this mathematical syntax with pure English, because why not? And here we have, like, Px is our explicit base condition, so that there are any developers in the room next door. Qx is our then clause, so they all work with Haskell. And B is our set, so all the people in the room. And now we can write this mathematical description of vacuous truth law as something like this. For all the people in the room, if a person is a developer, then they must work with Haskell. Okay, I hope that now it's more reasonable, at least from the mathematical part. But how all of this relates to Stream, allMatch, and Java at all? Because I'm speaking about some abstract things like some mobile phones, Haskell developers. How many of you even know somebody who writes Haskell? Like, I don't know nobody. Oh, that's the only person on the whole room. That's great.
It's my ex-student.
Great. So Stream is just this example with for all quantificator. And we can read it as for all the elements of our stream, if all the elements match a condition, then return true. And here is a beautiful screenshot made by me from IntelliJ IDEA with a compiler warning that states that we can just simplify this whole expression and write there true, because it will also always return true. And it is also a beautiful example that computers can into math. Of course, some of you, can say that I just made it all up, it has nothing to do with Java, nothing to do with maths, and it's just basically a coincidence. And here I am with a counter argument. It may be coincidental, it may not, but Java is not the only language where it works like this. In Scala, method for all, that is present in many collection interfaces, works exactly the same way. In JavaScript, method every from array prototype also works the same way. In Kotlin and Python, built-in method all will also return true for empty arrays. And a few months ago, I had the pleasure to speak with guys from Neo4j And we found out that built-in function all from Neo4j will also return true for empty arrays. So Java is for sure not the only language with such behavior. And when a health freezes, math will be actually useful in our daily life. So a quick talk around vacuous truth in real life. Besides, when a health freezes, we've got when the pigs fly, when shrimps whistle, when the stars start rising in the west. And all the other absurdities that are based around impossible to meet or obviously false condition. And if we want to be 100% mathematical nerds, because why not? Why shouldn't we? We can count all the statements based around if I were you as vacuous truths. I know it is basically a concept of language, the structure, everything, but if we want to be 100% mathematically nerds, it is vacuous truth, because I will never were you, so quite obvious. And as it's time for sum up this quick talk of mine, I hope that you will remember that vacuous truth exists, is a concept from mathematical field of logic, represents all the logical statement with a false base condition, is a reason why allMatch and their counterparts in other languages will return true for empty arrays and sequences, and can sometimes occur in real life. And maybe you use it today, or you will use it today, or tomorrow. It tends to occur quite often in our daily life. So if you like my talk and want to stay up to date with what I'm doing, you can find me on LinkedIn, mostly, on Medium, under this handle, and on SoftwareMill's blog, when I'm trying my skills as a writer from time to time. Do you have any questions? Now it's time. Anyone? Anything?
I got a question.
Okay.
So if you say that the base condition is false, and then you have the other condition, so like when hell freezes over, the sky will be red.
Yeah.
Then you can say when hell freezes over, the sky will be blue. And both are true.
Yeah, both are true because they are not even evaluated.
But it feels like inconsistency then.
Yeah, it feels like, why if from a programming perspective, you have a stream of one element, which is, for example, A, and, empty stream, and you made like allMatch, element of a stream is equal to B. And it will return true. Like, it doesn't sound logic, but nevertheless, it works like this. And it's, for me, after some digging around this, it sounds like, why 2 plus 3 is 5? Because it is. Like, because it works that way. And like, people agree to think that it works that way. Any more questions? Okay, so thank you for your attention. Have a great day, and have a great rest of the conference, guys.